I'm Ennemcien. Here's a problem for you. Two identical blocks, A and B, are connected by a spring. The spring is so compressed that A is tightly pressed against a rigid wall and B is held in its position by a stop. How will the system move when the stop is removed? This is the question. See the figure. A and B are two identical blocks, that is, mass is same. The spring is in a compressed state so that A presses against the rigid wall. B is held in position by the stop S. Here, the spring pushes the block A towards the wall and pushes B towards right because of the restoring force developed within the spring. When you remove the stop, B is accelerated towards right because of the restoring force. This acceleration continues until this original length of the spring is restored. Now, B continues its motion with this newly acquired final velocity. Till now, block A was at rest. Now it has no external force on it, but being connected to B, A has to share the motion. So the block A starts moving towards right at the expense of the force exerted by the spring. Spring pulls it towards the right. So the spring gets elongated in this process because there is a change of state of the block A from state of rest to state of motion. The extended spring develops again restoring force, which is towards right. It has to compress again to restore its original length. So the block A in this process is accelerated, and because of inertia of motion, it compresses the spring again. This process gets repeated and the motion of the system as a whole, when we observe, we see that A and B alternately come together and move apart. At the same time, in the absence of an external force, center of mass of the system, the load spring system must move with a uniform velocity. But the block will come together and move apart alternately. This is the answer to the question. When it is asked in the competitive exam, you can choose the proper answer from the choice. Thank you.